constants that come along for the ride. But I could definitely have gone straight to here.
So just because the y squared is connected to the x 3x to the fourth, it'll go along for the ride.
Yep.
So like if that was 10x y squared, then the y squared would come along.
Yep.
As well.
Absolutely. Absolutely. So now, let's do it with respect to y. Get in the habit of underlining your variable, guys, in a color. I don't care what color, but some color, so that you can easily pick out where it is. So what do you think this derivative is going to look like? I'm going to do it Caitlin's way. I'm going to just dive right in.
3x to the fourth and then 2 times 2y.
Mm-hmm. Or just 6x to the fourth y, right? That's what you wanted.
Okay,
Yeah, okay. So there's that one taken care of. What's the derivative of this with respect to y? 0. Doing it as a placeholder. What's the derivative of this with respect to y?
50.
Yeah. And the derivative of -8 with respect to y? Or -0, +0, whatever.
So you've got z, x, and y, and so we take out only what we need,
Mm-hmm.
and
That's it.
cool.
So you guys can see that this partial derivative is clearly different from this partial derivative, which is what I was talking about with the two different motions. If I hold one variable constant versus holding the other variable constant, you will get two different motions out of this. Yes?
I know that it doesn't really matter, but shouldn't it be like a -0 at the end right there?
Yeah, it should, but it's okay.
Do I get extra credit?
Nah. Because I said it as I was writing it. I was like, +0, -0, it's 0. Yeah, you're okay, Kate. She's like, I want the points. So let me rewrite this all together. 6x to the fourth y plus 15 minus 0. All right, so let me illustrate to you just how this changes. What if I were to give you when x equals 1 and y equals 2? So if we plug x and y into a derivative, what do we get out? Slope. Slope. In this first one, what's our variable? It's x. So x will be changing from 1 to 2. Y will stay constant at 2. You guys with me? Remember, we always vary by 1. Always, always, always. So let's plug the partial, let's plug these values into this. So 12 times 1 cubed times 2 squared minus 10. This becomes 12 times 4 is 48 minus 10 is 38.
Didn't you just say we make x 2?
What?
We go over by 1?
Yeah, so I would interpret this as when x goes from 1 to 2 and y stays at 2, z will increase by approximately 38.
Yeah, but we put x as 1.
Because I said x is 1.
And you said x goes from 1 to 2.
But it does.
But that's because you're plugging it into the function that was the derivative that's from in respect to x, right?
Mhm.
So that's why it's only focusing on x.
Exactly.
Going from 1 to 2.
Exactly. So Saeed, I think I understand where you are. Let me finish writing this and I'll explain, okay? Z will increase by approximately 38. Okay, so before in 2D, Saeed,
Yes.
we had a function, and let's say we plug x equals 3 and we get a slope of 10. So that is saying when x goes from 3 to 4, y will go up by approximately 10, always by 1. So we're now, x goes from 1 to 2, z will go up by approximately 38. Does that make sense?
Yes.
Awesome. So now let's plug those same numbers into this derivative, this partial derivative, and see what happens here. So let's do 6 times 1 to the 4th, my apologies. 1 to the 4th times 2 plus 15. Well, this is 1 to the 4th is 1. 6 times 1 times 2 is 12, plus 15 is 27. So now, when x stays at 1 and y goes from 2 to 3, z will increase by approximately 27. Emily,
How do you get 6x for y, like 6x to the 4th?
6x to the 4th, right here?
Yeah.
Okay, let's talk about this. I'm gonna get rid of the green part just to eliminate confusion here. So y is our variable. So let's first look at the derivative of y. What's the derivative of y there? 2y. Okay, what's 2y times the constant that's now gonna go along for the ride? So 2 times 3 becomes 6, x to the 4th, and the y. Okay, does that make sense? Awesome. How do you guys feel about this? Saeed, are you solid?
Yes.
Groovy. Talk to me, everyone else, my quiet ones. My very quiet ones. Yes, yes. Yes. Okay. All right. All right. Christina, you've been real quiet. You good? Yeah. Because, again, the last 2 lectures, you guys, my intention is to make them super easy for you. You slide into the finals, right? I want you guys to slide into the final exams. I don't want this to be the most difficult material you've seen. I want it to be the easiest material you've seen. So let's do another one. What, did we end at 10? Who picked 10?
Me.
Emily's the winner
Except
today.
I'm technically not in this class.
Yeah,
But you still
it's
showed up.
okay. You still showed up. We count you.
Yeah.
Yeah, your body. You walked in. I'm excited. Do you guys like it dark back there? Is it? Okay. You got it, man. I'm gonna keep it right like this for you today. It's hurting my eyeballs, but it's cool. Let's look at this one. Now, I'll start with y's and remember it's z today. Z equals x cubed